Hey guys, I have a quick little problem for you guys and a couple things that I want to share with you guys about concentration and molality and molarity. So the first thing I want to share with you guys is to always memorize the difference between molality and molarity. Molality is going to be your moles of solute over your kilograms solvent. And for your guys' case, most of the time your solvent is going to be water. And molarity is going to be moles of solute over liters of solution. So this is going to be your water plus your solute. Just so that you guys can remember that. This is like pretty important because if you're asked to convert from molarity to molality, you're going to have to get the mass, most of the time, mass of water. Or actually, this is what you're going to do. You're going to get the mass of the solution using your density. You're going to subtract the mass of solute. And you can get that from your moles of solute. And you're going to get the mass of solvent that you can then convert to kilograms and use that for your kilograms of solvent. Then go back and use your moles of solute there. I know that probably doesn't make a lot of sense not doing it within a problem, but that's how you would solve a problem starting with molarity going to molality. We're going to do a problem that is basically, I guess, it's giving you, well, this is kind of like a molarity problem. It really isn't, but we'll see it when we get closer. So let's go right ahead and get into it. The first thing that I do whenever I do problems like this is I like to highlight what I was given. So I was given 4 grams of sugar dissolved in 350 milliliters of water. And it gives you the temperature because the density of water is different at different degrees Celsius. And it's asking for the molality. And it says the density of water is. Another thing that I didn't mention is that most of the time whenever you're given, actually, anytime that you're going to convert between molality or molarity or anything, you're going to need density. So I think it's really important that if the problem doesn't have it and you don't have a table that gives you like a density table, then you're most likely not going to be doing that. So you just need to use context clues to figure out what the problem is really asking you. So let's go right ahead. So I was given 4 grams of sucrose over 350 mLs of solvent. I'm going to write solvent so that you guys don't get confused, but really it's water. But I feel like solvent's a little bit easier to understand, I guess, to see, so you can start memorizing it. And it's going to ask for molality, so our end result, we want to have moles per kilogram solvent. I used to always like to write what my last units will be in so that I know what to work towards. So I'm going to use my atomic mass unit. So I'm going to use my grams per mole of sucrose. So I know that 1 mole of sucrose is equal to 342 grams of sucrose. Now that I have moles of sucrose over milliliter solvent, now I can use my density of water, which is this number, my density of my solvent, to get that into grams. So 1 milliliter over 0.975 grams. And then now that I have grams at the bottom, I'm going to convert to kilograms. So 1 kilogram is equal to 1,000 grams. I'm going to go ahead and cancel out what I know is already gone, so I know what units I'm working in. My milliliters canceled out. I'm left with moles of sucrose over kilograms, and this would be solvent. So my units are right. Now my answer is 0.034, and you can write little m for molality, or you can literally write it out as 0.034 moles of sucrose over kilograms of solvent. So there you guys have it. A quick problem that you would convert, you would have to use density. Really, whenever we convert to moles over milliliters, we are in kind of a molarity, except we're not in liters. And in this case, we wouldn't have had to use this method that I mentioned up here. But you'll see in different types of problems that it will be necessary to use that method. If you guys have any questions, feel free to email me or come to my office hours. Even if you want to come to office hours that regarding to different topics that we've already covered, feel free to do that. But yeah, keep up the great work, guys. We're almost done. Go Frogs!